Welcome to the afternoon session. This presentation is on MIPI touch specifications, MIPI mobile touch. It's being presented by David Johnson. David Johnson holds a Bachelor of Science degree in Electrical and Computer Engineering from North Carolina State University. He has spent his career, he works at Qualcomm, obviously. He has spent his career working in system engineering, supporting customers in consumer and networking markets. He joined Qualcomm last year after his group was acquired from Maxim Integrated. He currently leads the software and systems group for touch in Santa Clara. This presentation was also, I think, a key contributor was Mr. Dale Stolitska, who is a principal engineer at Samsung Display America Labs in San Jose. He leads interface standardization. He chairs the MIPI display working group under which the touch specifications are being developed, and is an active in other industry standards setting organizations including SMPTE, VESA, and JPEG, and the MPEG working group under ISO IEC. He has led the MIPI display team since 2008 during periods when the MIPI display serial interface added deep color depth, stereoscopic formats, display compression, split link architecture, and broader support for MIPI physical layer advances. So please welcome David Johnson. Mr. Johnson.
Let's see here. Yes. Yep. Good. All right. Good afternoon, everyone. So I want to talk today about the MIPI touch interface standard we're working on right now, and ultimately solicit you to join and help us along this process. So why do we want to create another standard? What's the goal here? So there's a couple main things right now if you look at the current environment for touch. First, there's many different proprietary solutions, none of which share the same interface, which means that at the customer level, they all have to develop their own software, they have to be doing their own drivers, and they have to redo all this work. And so it's a lot of impact on time to market and engineering effort just to simply be able to use multiple solutions. Secondly, there's now becoming multiple interfaces depending on the amount of bandwidth that a touch solution requires. Now I need different interfaces which are not compatible, different numbers of pins, none of them are particularly power optimized, and so we're trying to address this to create a simpler thing for customers to be able to work with. And then finally, ultimately there's new efforts going on in the touch space which require more interface, and more interface than what has always been the traditional touch interface of I2C. And that's led to, as you see earlier, the SPI, but also looking at even higher than that. And so one of the goals here is to try to provide a path through the MIPI ecosystem to support touch and allow the end customers to be able to easily move between solutions. And I just talked to the wrong slide. Oop. Sorry, so here's what I was just talking about. Now I realized I've got two slides here. Okay, so I've covered these. One of the things on optimized, especially when we increase the power requirements or increase the bandwidth requirements, is we're really concerned about efficiency at pin usage as well as efficiency for power usage. If I want to push more bandwidth across a pipe, I want to make sure it's optimized for power and enable us to do that more efficiently in that mobile environment. So what does this really mean? We went out, and this is within the display working group, and we talked to a number of different companies and basically solicited their inputs. What do you think are the key touch use cases? What do you think are the requirements within those use cases? Things like, what are the frame rates you expect to see? What are the node counts or the pitch on the touch screens? How many fingers do you want to support? All these types of, what interfaces do you foresee? So that we made sure that we understood kind of what our members felt were the needs of this market. And then the next goal is we want to create a solution within the MIPI ecosystem. So what does that practically mean? That means first we want to leverage the I3C interface as the first step in a high-speed bus that supports both traditional and future interfaces. Secondly, if we find interfaces in the future requirements where the bandwidth needs to be even higher, we want to continue to stay within the MIPI ecosystem. So we'll evaluate additional MIPI interfaces to provide higher bandwidths as required. We want to be able to work with the device registry, which I think has been discussed in some of the other conversations in terms of using that as we have this interface and these profiles that are set up. And then finally, we want to work within MIPI with other working groups. So we're working with the software working group, the sensors working group, to make sure the solution we're defining works within that ecosystem and works with the rest of the groups in place. That's live too. So what kinds of things did we see? What was the feedback we got from the different members as to what they felt were key aspects? So multi-touch, everybody kind of expects this as part of the standard thing you're going to see in a mobile platform that supports touch. But what we did see is a pretty wide divergence in what's the frame rate people foresee. And this wasn't just right now, but this was even, what do they see in 3 years? What do they see in 5 years? What are the trends they see? So there was definitely perception that the users expect to see a higher frame rate. They expect to see more nodes, so basically tighter pitch to enable different types of use cases, whether that be styluses or different aspects of working with fingers and how they want to be able, what kind of resolution or what kind of fingers they want to support. And so that was one aspect we saw. Additionally, there's a desire to go for new use cases that aren't kind of in the traditional touch space that you'd see in most general purpose. So there's a push for stylus, and some of that may be done passively, but it also may be done actively. And there's a number of standards, other standards out there that are trying to do that, and they wanted us to make sure when we worked on the touch space, we were aware of what the other standards were doing and we were not conflicting with them, that we understood their requirements and we included that in the standards that we worked on. And then kind of longer term in the sort of along the other areas for MIPI is we also want to be aware of what's required for automotive. You'll see in the discussions that we'll talk about a little further, there's nothing explicitly targeting automotive right now, but one of our goals out of the standard is to make sure we're not doing anything that actually would impede a future solution in that space. So we want to be aware of what their needs are and make sure things that we put in the standard are somehow going to impact our ability to address those needs more directly in the future. So what's the system that we're talking about? Kind of what is this, how did we envision it, how do we break this down? So there's a few key pieces. So the one that everybody's used to seeing, here's the touch screen. And then attached to the touch screen, and there's basically two different common phrases used to describe them. One is TC or touch controller. So this is kind of the traditional touch solution. All of the detection, all of the measurements are done, as well as all the processing. And ultimately out of that comes point positions. It says there's a finger there, there's a finger here, there's a finger there. There is another type of architecture that is coming into the market, which uses a different approach, which is called this AFE. And basically all this means is I have the analog portion of the system down on the IC attached to the sensor. So what I'm going to do is I'm going to do all the data acquisition, but then I'm going to leverage the processing in the upstream applications processor, and I'll push all the data in, and then I'll let it handle that processing. And so both of these solutions are in the market now. Both these architectures are in use, and they have different requirements. And so the current problem the customer faces is what I do here and what I do for the touch controller side and what I do for the AFE side are different. They're incompatible with each other, and therefore it creates an additional burden on me, the customer, if I want to have the ability to choose between those solutions for different designs or different applications I can't easily reuse. So one of the goals here is, how do I make this look the same no matter what I'm attached to? And so the customer doesn't have to bear that burden. The other thing you see here is we kind of divided this up into two sections. So this is, and we'll talk about a little later, the area we're primarily focused on, which is really the AP touch controller interface. What's the bus we're going to use? What's the command types we're going to support? And then there's a separate section which we look to address in the future, which is really now looking at, and now let's from the OS side down to the AP, because for our customers, this and this are both things they have to deal with to some degree or other, and therefore anything that changes there creates additional work for them. So if we can create standards along both of these areas, that simplifies their life. It makes it so where they just develop for one thing, it works, and they don't have to think about it further. Digging a little further into this section here, you see a couple different things are illustrated. So again, here's the touch panel. Here's the analog portion, and so if I was only going to implement an AFE as a controller. In general, I basically have all of this. There may be some additional supporting digital, but this right here then hooks directly upstream to the AP. If I'm a traditional controller, I add on this additional block, which now manages the touch processing as well. And both of these are transported back to the MSM. One of the key items of what we're working for is we want to shift to I3C. I3C provides us a couple very nice features. One is it gives us higher bandwidth, and we can dynamically move between the bandwidths as appropriate for the design you're on. Secondly, I can actually include additional devices, even traditional devices. So it lets things like, maybe I have multiple touchscreens because I have one in the front and the back and I want to handle them differently. Maybe I have just general sensors. I have some traditional, I have an I2C PROM or something else I need. All of those can be easily integrated, where in the current situation, it's not an easy thing to get put together. And then within this, we want to use these touch profiles to help have the MSM and the touch controller or AFE side talk, as well as we'll talk about these standard commands. And so basically create a standard command language that enables customers to have a set of behaviors they're expecting the device to do, and assert a command, and the command takes a known action. There is support because we realize that within the solution providers in the touch space, they all have different ways to do things, and there's proprietary nature, and so it has both the understanding of a proprietary command set as well as a standard command set, with the goal though being to enable customers to have an easier process to bring these up. So requirements. There's two requirements primarily that's come out of the initial discussion. One of them is bandwidth, and another one is power. So especially when we start talking higher bandwidth, one of the big concerns has been how much power am I burning to get this bandwidth? And if especially for the places where the bandwidth is going to be something where they really want to dramatically increase it, it needs to get more efficient. And so how to do it? The I2C interface is not that efficient. Even the SPI can be not that efficient. And so one of the targets that came out, and hopefully everybody sat in the I3C presentations this morning, these are driven from the I3C side in terms of trying to make sure that we're leveraging the capability and all the work the sensor group has done on that interface. We want to leverage it and benefit from it. So how do we foresee this system? And I kind of gave a hint to it in the earlier slide when I showed the kind of how we had it divided up between the AP and the OS. So right here you see this is basically equivalent to that touch module picture I showed. And what we're looking at is this is what we want to address in the first effort on the standard. There's a lot of things. If you look all the way up to the top of the stack, you're now talking Android and Windows. So there's a lot of breadth in what this ultimately will encompass. But we want to start in pieces. And so the first piece we want to address is the bus interface. So let's standardize on I3C. Let's standardize on the methodology that will use I3C to enable the profiles and enable the behavior. And let's standardize on a touch command set. And by doing that, it will enable us to already improve the situation for end customers who are trying to design these into their systems. And then in the future, we want to move further up the stream because we recognize our customers still feel this pain whether we address it or not. And we'd like to try to make that pain go away as well. So how does this, I said at the beginning of the presentation, our goal was to kind of try to fix the current situation, make it easier for our customers and make their lives simpler. So how does what I just showed you actually help in this way? So one is, the intention is the command set's designed to be written at a level where it's OS agnostic. So the OS doesn't figure into it, it's below that level. It's not involved in it. It also has the benefit of, by standardizing it, making it simpler for customers to integrate with and have known expectations for behaviors and how they can interface with these devices and have them work appropriately. One of the other things we want to make sure going forward, and from I3C we get it naturally, there's already a standard way, two-way communications on I3C. But if we have to go to higher interfaces, one of the things we want to ensure is built into the standard is we will always support bidirectional communication, a way for communication to go back and forth as part of sort of a fundamental of the standard to enable that. We also want to be sure that we're not going to disable any use case our customers or members wish to enable. So touch is, whoops, wrong button. Touch is one we already have, but with the new standards that are coming out supporting different types of pen, different types of information associated with pen, we want to ensure there's nothing in this standard that would prevent that. In fact, we want to make sure it enables that to seamlessly ride across this standard and across this interface. So that from an end customer perspective, what they choose to implement just works and they don't have to think through what's the differences. And as I mentioned earlier, we want to use the new i3C. We want to use that because we think there's a lot of nice things it has, nice features it has in it that really make it much easier for us, and it makes it much simpler from an end customer perspective who wants to be able to have high bandwidth for certain things and lower bandwidth for other things, and even may potentially dynamically switch between them. So I said we're going to leverage i3C. What do we see as the advantages this i3C is going to give us? So the first is going to be, it's going to give us the ability to optimize for speed and power. So it's one, the interface and the bus itself was designed for power, and from our perspective, we see a lot of nice enhancements in what the bus already has defined that we can leverage to simplify the touch interface, to simplify the mechanism by which AP and touch communicate with each other and basically understand what's going on. It's also been pin optimized. So any interface we talk about right now that's in the market always has a separate interrupt, may have additional pins depending on which one we pick. Now we all of a sudden have the ability of in-band interrupts. So we save another pin, which can be helpful on the FPC side. It also could be helpful on the MSM side or others where they're trying to save on the amount of pins. It also already has built into it, so we don't have to go invent it, protocols for bus management. It understands how to deal with traditional solutions, different speed solutions, all hanging off the same bus. That's already part of the spec. So for us, that's not a solution we have to go worry about. We just adopt exactly what i3C already has, and we leverage it directly, which makes it an additional benefit to our end customers. And the last one is the improved bandwidth. So in other words, we can support, for at least in the mobile space, we foresee we can support the needs to support raw touch being where I shift all of the capacitive data up to the MSM for processing for the foreseeable future. So this is a key thing for handset being able to do that seamlessly and let customers be able to choose an architecture they want to use for a given design while not having to worry about changing the bus and changing the pins and changing everything just because they want to switch architectures for a different application. So on the touch command side, on the touch command side, kind of what do we envision? So one of the things, we're not trying to dig into it. Certainly not to start. I think over time things will evolve and additional commands will come along. We'll find places where there's more continuity. But right now we want to start with basic commands we recognize all the customers are using and need on a regular basis. So things like software resets, power mode configuration. So being able to tell the device what mode you want it to be in and what behavior you're expecting, which can be useful for solutions where they're trying to be able to do power management or other controls. Self-diagnostic functions. So I don't have to know some special way to get a touch controller or an AFE to actually tell me if my touchscreen is still behaving correctly or if there's some problem. I can issue a standard command. It can run a sequence of diagnostics and basically report back. Just generally being able to get the touch information, whether that be raw, which being the full frame data, or the specific reported points. Both of those need some standard way to do it, and it's not standard right now. And this provides a way to have a specific command that automatically handles that. And then as I mentioned, we recognize there are, all of the people in the touch space have their secret sauce, and they want to be able to continue to support their secret sauce and let their customers benefit from it. So we recognize that, and we want to make sure that we provide a mechanism for proprietary commands that will support those types of added behaviors. This is also the way in which we can support other standards that are external to MIPI, being able to still ride on the top of this interface because that also provides them an avenue or a channel by which they can operate. So I talked about one of the key aspects of this is we want to work across the organization. So it's the software working group, the sensor working group, working with the Stylus standards, working without having a dependence on what OS, so that we basically, the first version of the standard is able to address the majority of the market quickly and also work within the MIPI ecosystem to leverage all of the hard work by the other groups. We're happy to ride on their hard work, and we will leverage that to the maximum degree possible. And then on the planning side, to give a sense of what is the timeline. So I mentioned we've already spoken to members and other interested parties and solicit inputs as to what are your needs, what are the things you see as the requirements both immediately as well as 3 years out in different screen sizes, frame rates, touch, et cetera. We've done the first pass, and we've actually put together an initial draft standard, which is 0.2 right now, 0.2. The intention is to go to 0.5 here around the MIPI meeting in Singapore, and then ideally by the end of the year be to 0.7, with the goal being by 17, we then have a final release standard that comes with all of the other standards being released that we'll be leveraging. So this is our current timeline, and we're relatively on track to the original timeline, which is about the same thing. Okay, so what are the things in conclusion? A couple of things. One is we want to support standard open software. We want to make it so that a customer does it once, they do it to something they already can read about and understand, and it just works, and they don't have to redo it. We want to make it so that their design activity is easier, less additional engineering work. So this is what we think Touch Profiles adds to it. We want to allow standard commands. So once again, I'm preventing additional engineering work that I have to customize for vendor A versus vendor B versus vendor C. I do it once, I don't have to worry about it. And this is going to add time to market. We want to leverage all the hard work from the sensor group to use the I3C interface to leverage both the speed benefits it provides as well as the power optimizations. Additionally, we want to leverage the ability to use this in-band interrupt. And there's some very nice features that have been built into that actually allow us to do some embedded two-way communications on these interrupts that we didn't historically have the ability to do in the other traditional interfaces. So there's actually, in looking at how the sensor groups defined it, we found some very nice things we like that we want to leverage and take advantage of. So next steps. If you're interested, join the display working group. Help give us your inputs to make sure that what we generate meets your needs. Pitch for the sensor group. Start using I3C. It really will make things easier when you start having to have different bandwidth requirements than traditional I2C is supported, as well as the ability to handle multi types of devices on a single bus. And hopefully you didn't miss the I3C presentation this morning, because we're already leveraging that maybe in the slide deck. And then thank you to many people who've worked this together, and I hope people have questions, because I must have talked too fast.
I think that's it.
That's it, if there's no questions.
Take questions now. You have Did we get scheduled for the I3C also?
Did we get scheduled?
When do the sensor calls?
Did you have a schedule for I3C to show the lines up?
I don't think that Ken included a schedule, but he did say that you did say we were at the close of first draft review, yeah. So, which is pretty near the end, after a couple years of kind of hard work, sort of. Yeah.